The Zero Trust framework assumes nothing, and no one is trusted by default, requiring continuous verification of every access and action. In infrastructure operations, this extends beyond identity and network controls. It also examines how changes are executed and how automation is implemented. Every configuration change is policy-driven, auditable, and validated end-to-end. The Chef 360 platform enforces zero trust by acting as a centralized governance and enforcement layer for infrastructure automation. Instead of relying on direct SSH access or one-off scripts, all operational changes flow through structured, policy-driven workflows. This creates a clear zero-trust boundary between operators and infrastructure, with validation, enforcement, and auditing built into a single controlled pipeline. With Chef 360, teams can validate policies before remediation, run only authorized actions on approved targets, verify compliance after execution, generate audit-ready artifacts, schedule jobs to continuously enforce compliance. We begin by logging into Chef 360 and navigating to Courier. Courier is the workflow orchestration engine within Chef 360. It allows us to create new jobs, duplicate existing jobs, use predefined templates. In this scenario, we duplicate an existing job to maintain consistency with a unique job name and description. Because compliance must be continuously verified, not assumed after a single execution, we can schedule this job to run periodically, since it's critical to a zero-trust model. For this demo, we execute the job immediately. Now, we examine the internal workflow of this job. The first step uses the inspec interpreter and pulls control files directly from GitHub, executes defined compliance controls, stores the results in the output variable inspec value. Here, remediation is not blind. It is conditional on policy evaluation. This represents the zero trust principle. Verify before action. The second step consumes the results from the first step, and, if remediation is required, uses the Ansible interpreter to execute a controlled Ansible playbook. The Chef 360 platform allows multiple playbook sources, local execution, HTTP or HTTPS endpoints, or S3 buckets. In this case, we execute a playbook that enforces the desired service state. The third step uses the shell interpreter to execute a structured script that captures node metadata, records pre- and post-enforcement state, calculates risk score, records policy ID and execution authority, logs execution duration and results. This reinforces traceability and forensic readiness. The final step runs inspec again. This performs post-remediation validation to confirm the machine matches the declared policy, all required controls pass, and that the system is compliant. The results are stored in the output variable inspec results. This step adheres to the zero trust principle. Verify after action. From the terminal, we confirm that the SSH access is restricted, direct administrative remediation is not being used. From GitHub, we inspect the inspec control definitions, policy stored as code, approved baseline. This demonstrates separation of duties and policy traceability. As you can see, the demo application displays zero trust boundary violation, failed control validations, and that the overall state is non-compliant. This represents configuration drift. We then return to the Chef 360 platform and execute the job. The workflow runs pre-validation, conditional enforcement, audit capture, post-validation. Execution completes successfully, and we see the status is marked as success. After refreshing the browser, the zero trust boundary is marked secure. All policy validations show pass, and the overall state is compliant. This confirms policy-driven remediation and verification. The Chef 360 platform provides downloadable artifacts, which include job execution metadata, step-by-step logs, inspec control results, pass or fail breakdown, execution timestamps. These artifacts enable reconstruction of the event, policy compliance validation, and operational audit support. This demo illustrates a zero trust operational model where no administrative action is implicitly trusted, all remediation is policy gated, the infrastructure state is continuously validated, execution is mediated through a centralized control plane. Every action produces verifiable audit artifacts. What we demonstrated here is not merely automation orchestration. It is policy-driven, continuously validated, centrally governed infrastructure execution aligned with zero trust architectural principles. To know more about how Progress Chef can help you adhere to the Zero Trust framework, visit us at chef.io.